PUSH2PROD. PUSH2PROD is a really great effort that we've seen come together. We've got an incredible amount of content that's been brought to this stream. We've got it's a two-day event. We're in day 1 of 2 right now. So a big thanks to all of our supporters and all the folks that have brought content. And in fact, we've got a lot of them who are right here on this very panel. So I'm very proud to be able to help to moderate today. We're going to talk a little bit about cloud native practices, learnings, lessons, and the challenges. I think that's probably the most important thing. We could all talk about how great it is if you're already all in and it's going well. That's congratulations. But for the rest of us who are trying to figure out what are the right things to do and what are good lessons we can learn from each other, this is a chance to do that. My name is Eric Wright. I'm the technology evangelist here at Turbonomic, who's part of the supporting and presenting team. And I'm going to go across my camera line here to introduce all the folks. I'm going to begin directly to my right here and welcome aboard Jim Walker. Jim, if you want to introduce yourself and tell us where you're from, and we'll make our way across the line.
Sure, you bet, Eric. Hi, happy to be here. Happy to meet all you panelists as well. I'm Jim Walker. I'm the VP of Marketing at Cockroach Labs, which is a distributed database, a cloud-native database.
Excellent. And Jochen Mader, not just a great cyclist from you can see in his background, but Jochen, if you want to introduce yourself and tell us where you're from and where we can find you online as well, if you're like for folks that want to connect.
Yeah, so my name is Jochen Mader. I work for Instana, which is a SaaS-based APM that is also delivered on-premise. So we do basically all the things from MultiCloud to delivering to the customer directly. I'm part of the engineering force at Instana, and my team is mostly working on the on-premise stuff in cooperation with all our SaaS deployments that we do there. So we got the whole range in there. And if you want to connect with me, I'm on Twitter as CodePitbull. So that's it. And like my talk was just on. And I'm also very happy to be the first time I do it like this panel discussion.
And for folks who didn't catch the live shot of Jochen's talk, best use of Lego ever in a presentation. Really, really great. I love the style that you chose. Really told the story well. So thank you for that one. Endre Sara. Endre, I'm lucky enough that I know you well enough from 6 years of being together here at Turbo, but why don't you introduce yourself to the folks and see, tell us what you do here.
Sure. Hi. So my name is Endre Sara. I'm the VP of Engineering at Turbonomic. I've been with Turbo since we started the company. That's over 11 years now. I lead basically a team of developers that are applying our technology, our platform to solve exciting new problems, various problems over the last 3 years. Most recently, we have been focused on helping our customers to manage cloud-native applications on any cloud, both on premises, bare metal, or different public clouds. I'm very excited to join the panel and all the other panelists. Thank you, Eric.
Excellent. Thank you, Endre. And last but certainly not least, joining our panel today, Josh Wood. Josh, you want to introduce yourself and tell us where you're from and where we can find you?
Hey, how's it going, everybody? I'm Josh Wood, obviously. I am a developer advocate at Red Hat. I talk obviously about OpenShift, our Kubernetes product, but specifically in that area about operators and the ecosystem we're trying to build around automation and SRE ideas in that space. I was formerly responsible for documentation at CoreOS. Jim and I have met before, as a matter of fact. I only realized at the last moment that he was on the panel with us. Let's see, I'm originally from Kansas City, Missouri, and I just recently moved back here within about the last year. I'd been working in San Francisco for quite a long time before that. Where can you find me? I'm on Twitter if you want to look. The handle is JoshX9. Which is a Plan 9 reference.
Nice.
For the 3 people who might catch it.
Any Ed Wood reference is always appropriate, so I appreciate that. Now we're going to kind of cover the gamut on content, and as I mentioned at the start, when it goes well, it's great. not as compelling a story. It's nice, but one of the things I think is important, and we get asked all the time, and of course for folks who want to feed in questions, we can take them live on the chat. We're actually streaming on a few different platforms, so just drop in a question in the chat if you want to catch us live, and we'll pick those questions up as we go. I want to start. We'll go sort of the same order then. How has the cloud native approach and fundamentally shifted how we operate both the infrastructure and kind of the app architectures? Because what I find is a lot of folks have all these what we call best practices, which were point in time and they were meaningful, but we've effectively, like an Etch-a-Sketch, have just shook them out completely as we move to cloud native. And what are kind of, if you could lay down maybe even like one top thing that has been a fundamental change in how you have to think and operate in a cloud native architecture.
You're starting with me, Eric. You're going to start with the marketing guy, this panel of like awesome technologists. Or like, Josh knows me though. I'll stand there with you guys. So, it's funny when I was actually first introduced to Kubernetes, it was before I joined CoreOS. There was a small company called Kismatic that was actually a small distro. And, I was working with that team, and, I just had never been involved with that whole like distributed systems thinking. And for me, like the biggest transition, and that's 4 years ago now, or 3 years ago now, whatever that was. It was a complete mind shift in terms of how I thought about everything, actually. Going from kind of single monolith or kind of that world, which, VM and that whole kind of that push of everything. Everything went to a matrix. Everything went to distributed, including where I had landed, actually ended up is, I come from the data world, and just thinking about your application in a wholly different way. Like, I'll let everybody else talk about the infrastructure side, but at the application layer, really breaking things down into a matrix and understanding performance across functions within an application, as opposed to, the application itself. Really becoming services based and breaking things down so you can actually, extract efficiencies at that application layer is really ultimately where I landed. I mean, I coded applications. So for me, coming from the ground, all the way down in the depths of the stack, from the infrastructure all the way up to the application layer, it's commuting and translating the concepts of which your infrastructure is landing on into the application layer, and becoming truly distributed in your thought in terms of how you architect your applications, because ultimately that does tie to the deployment. And so we're no longer divorced of infrastructure and application layer. You kind of have to tie the two together. And I think that's I'll be the marketing guy and talk about the application. I'll let you guys talk about like the deep down tech stack, but I hope that's valuable.
It's great. No, and I think it's a perfect launch point. It's and funny. I'm as a fellow who's in the marketing team, I can proudly speak. We can still be technical in marketing, and coming out of the tech world myself. It's funny.
Don't laugh, Josh. Don't laugh.
I am the rare. I commonly describe myself as being involved in marketing, and I think even when we're doing documentation, we're always kind of relating it back to what it means for marketing the kind of DAO of a product or a way of doing things.
Yeah. We're translators is what I think of anyway.
Well,
so
that's it.
Sorry, thanks, Eric.
Yeah. Jochen, I'm curious in your thought, and it's a perfect lead in. You talked about the importance of the app, Jim. So Jochen, in the microservices APM world, and thinking about what do we do to tackle some of that? What's your experience, and what are some hard lessons maybe that people need to think about as they move to cloud native?
I mean, like the good thing for me was that before that, I switched over to Instana. I was 10 years in consulting and actually building up microservices infrastructures. So like the key thing is that when you go into this world, especially into the cloud world, that you need to get like your insights. I mean, like that's all like, I mean, ultimately that's what we're trying to do, is just like to keep track. Because like, it's not like this one single monolith. Like, I mean, like, I'm coming back from the 90s where you had like everything on one machine. You had like the PHP, you had the Apache, you had like maybe a database, and that was pretty much it. And now you have, even for smaller applications, you have 10 to 20 different services distributed across your Kubernetes cluster, or even broader. You have a lot of backing services that you use. You integrate SaaS applications from other providers. So there's a lot of things to track and keep in sight. And the other big thing for me, I think, for this is that a few years ago, you could still get away with automating every single piece of your application infrastructure. Today, no way. Like if you try to go into the cloud without like a solid automation in place, you will fail for the simple reason like you cannot sustain deployment speed, and you won't be able to get the use out of what you actually have there that you can do there. So that's like my main takeaway, especially like from these new style of applications where we start distributing more and more.
I like where you're heading with this, Jochen, and again, really good lessons. We lost Jochen's video there a little bit with that one, but we're a little bit of bandwidth. That's the one thing. Zoom, MultiCloud, God bless them, but they run into their own challenges themselves about latency. Indra, performance, you know this well, but I won't pull you into where you need to go. What are some of the cloud native lessons that you've most likely learned yourself in replatforming even our application as well?
Yeah. So I think one of the most interesting thing when we started now several years ago, both in terms of working with other customers as well as replatforming our own software as a cloud native microservices application on top of Kubernetes, is that there was this premise or promise that because these microservices are going to run independently and scale independently from each other, it's going to be so much easier. We're going to have less bugs. We're going to have less performance problems because we just basically look at this one component, we scale that one component, and then magically everything is going to work together. And it's not, I'm not playing down the benefits and the importance of a microservices architecture, but one of the biggest learnings from is how much more complex operating a microservices application is going to be. And I think Jim put it very well. Matrix is probably the best word to say this, because there are so many very well-intentioned interaction between the several microservices. So for example, I make a change, I change the way I consume Kafka messages in this microservice, which suddenly drives up the CPU utilization, which then feeds off to another component, drives up the memory utilization, and I end up slowing down, 3 components down the overall processing of the data. And understanding these dependencies and managing these dependencies, not just in a test environment, but especially continuously in a production environment, is super complicated. And it does give us a lot of flexibility. I can solve problems that I couldn't solve before. But to be able to manage this and operate this and assure the performance, provide a level of service overall from a perspective of an end user is a lot more complicated. And there are things that can fail because I fixed one problem here and I'm now triggering another bottleneck there. And then, of course, all of that still layers on top of the infrastructure. So now you have to be able to manage the infrastructure in the context of many moving parts, especially in a multi-tenant environment, but even for a single microservices application. And for example, me as a developer would have enough trouble figuring out how to operate my application. You absolutely need automation to provide the infrastructure resources that I need. Preferably, I need, of course, the automation to manage my application lifecycle as well. Obviously, a nice call out to operators, which help me to do that much better. But I think it becomes a lot more complex. And we need more software and more automation to be able to do this.
Yeah, it was the old line Jamie Zawinski was famous for saying, I have a problem and I use regex to solve it. Now I have 2 problems. I have a problem and I'm using microservices to solve it. Now I have 19 problems. Like it scales rapidly as the complexity does as well. Josh, being the developer advocate amongst us, you're very close to the app builder and definitely the experience for them. What's that experience in the shift to cloud native, and how has that changed that side of the world?
Well, yeah, for sure. And at Red Hat, we look at the advocacy role as being a two-way street. That's a lot about carrying those experiences back to product design and development teams at Red Hat and trying to influence product design sort of with a customer or a developer orientation. In light of the question, like, how has it changed how we've thought about systems? I think I have a short summary. It'll bring me to a point, I hope. But when that goes something like this, which is, I think, as almost everybody else has alluded to, there's been an explosion in complexity that's come along with the advantages of microservices and the containerization that serve as a mechanism for isolating those services and units. So we've made some engineering trade-offs there. Jochen alluded particularly to kind of the proliferation of services in these kind of architectures. And Endre alluded specifically to increasing application level developed complexity as infra concerns like this kind of leak up into that application layer. Now, we think long-term the advantages of that pay off and give us an architecture that works better and gives us places to automate, but the key is that word automation. So all of those things are driving us towards, one, automating and finding places to automate, or as we've talked about in kind of operator terms, we're always looking for work that my computer would love to do, as opposed to a human intervention being required. So that in kind of an iterative process, we make a system that's more and more self-configuring and self-tailoring, which can sound like magical buzz terms, but really they just mean having software that can examine the right metrics and then take programmed actions based on some kind of internal state. The trick is doing the programming for that internal state at the right layer. So you wouldn't want all these things crammed into a general purpose orchestrator like Kubernetes, but operators and kind of the structure, even at the Kubernetes API level of CRDs and a designed in point to extend that API, are the space where we think we can write those automations as we learn more and more about what they should be and what the problem space requires. So I think that proliferation of services and that increase of complexity really does point back to automation. And I think where we can automate on top of Kubernetes without violating its generality becomes a really important space. Vendors of infra use it to extend those platforms for their products, and application developers use it to make their apps easier to consume and easier to manage over time, sort of in terms, and this is something Jim alluded to in terms of distributed system thinking and practices. So designing for failure and designing for multiple network domains and kind of the practices that entails.
Now, one of the interesting things is the long tail of technology. And I find that as fast as we can bring in new things, we talked about OpenStack. We were talking about, in 10 years, we're going to be talking about the dawn of Kubernetes being around the corner. I'm sure, because we'll have found somebody that it's new to them and it'll be version whatever, right? So, and we won't have gotten rid of the other thing. And so we talked about push to prod. One of the big focuses is multi-cloud. And where I think this cloud native, it can be virtualization. It doesn't necessarily need to be public cloud, or it can be private cloud. It can be whatever. And I'll start with you, Josh, because again, taking the advocacy sort of point, when does multi-cloud become the driver for cloud native for real as well? I love, people are always like, let's do this so we can go multi-cloud. And the number of apps I've seen run successfully in multi-cloud is somewhere less than my hand can count.
Yeah, so that's it's a funny point, because I actually have just been discussing this and thinking about it a little bit earlier today. I will come clean and admit that I have been a longtime skeptic of the idea of multi-cloud. Like, I always, in my brain, reflexively or instinctively, I think, how many people really write portable applications with a systems level language, right? Like, Go makes that pretty easy and has this kind of build system oriented to it. But, a lot of the C programmers, there's a single CPU architecture underlying where they're aiming. And I always thought, who really wants to do portability among multiple clouds for the advantages that I'm able to just enumerate without doing research? But then I look at numbers. Like, I just saw something from Cloud Native Computing Foundation, the CNCF, and they say that of the respondents to their survey, which is going to have some selection bias in it, obviously, but of people, of companies that have a public cloud production scenario, they're running something that's real and it's in a public cloud, 80% of those companies say they're working with more than one public cloud. So I have to admit that my instinctive suspicion of this is obviously not matching what the industry and the market are really doing with it. So I find that a little bit surprising, but it's something that I've started like willingly giving ground on conversations. Like I had to be wrong about that. So
well, you hit a good point there, Josh, in that I think the definition of multi-cloud is one that we struggle with. Multi-cloud assumes that it's one app that will run in multiple clouds versus having multiple clouds as part of your IT ops portfolio, which I think is you're kind of already heading there, but that's the reality. And I think where the CNCF is seeing that in proof. And it's sometimes you don't have a choice. You could be like, I'm all in on one public cloud. I'm like, this is it. I'm only going to go with one method. And then you acquire a company and they're all in on another cloud.
True. Yeah. Or for a lot of Red Hat customers, that motivation is towards something that sometimes gets tagged with this other phrase, hybrid cloud, which kind of implies private and public. But for a lot of our customers, it's a regulatory issue or a performance issue. You built a fancy microwave network between New York and Chicago to do high-speed stock trades with a millisecond advantage. That work is going to stay in those two data centers, whatever your public cloud strategy is, right, for the foreseeable future. So there's this whole list of motivations that I think map to different enterprises. And so that's really kind of key to our thinking in what you see in OpenShift v4 in trying to package something that is that hybrid cloud experience where we have some common control plane that we can move between those environments. And like, so that's key to the idea of some of why we want to deliver things in open ways by extending Kubernetes at designated points of extension instead of like having a fork or something that's very, very intrinsic to what Red Hat's doing in one product or what some other vendors doing in one product.
Yeah, let's hope that we, having all of us, I think, lived through the challenges in the OpenStack, big tent, and looking for the right ways to scale the features and capabilities. I think we struggled. So hopefully Kubernetes will succeed on the back of OpenStack having tripped. And, with that, Jim, we talked before we started about some of the background. And so cloud native, multi-cloud for you, where are you seeing this multi-cloud story play out in some of your customers?
Yeah, so unlike Josh, I have been an advocate of the concept of multi-cloud for quite some time. I mean, since the demise of the kube-fed SIG, right? Like the Federation SIG is what it's gone to. Like the whole concept of federating Kubernetes clusters, I think is like incredibly difficult to do. I look forward to the work that's coming out of like Crossplane. I love what Bassam and Upbound are doing. Like, I think there's some really cool things at that layer. I think Josh nailed it though. There's lots of different ways to define multi-cloud. Are we talking about federated clusters and one layer of compute, or are we talking about all the way up to the application layer where it is a single application that is deployed across multiple clouds? I don't care what network and security is underneath, right? Like, and so, for us at Cockroach, we've truly built something that is actually the other end of that at the application layer, a database that's truly multiple cloud. I could spin up a node of Cockroach right here on this laptop, pointed at a cluster. As long as I have a TLS connection, I'm participating. I'm a single database, and I have a node, a gateway, an endpoint that's exposed right here. And and there's lots of different things, but there's a lot of problems to solve because nobody's doing this. We're all living in the future right now. Like everybody on this panel and pretty much everybody who's in this conversation and is viewing this stream, we're all living in the future. Nobody gets this stuff yet, right? Like these markets and these trends, they go through these adoption cycles where we all understand what the problems are. We're kind of waking up to it. Like, what does multi-cloud mean? I created a conference last fall called the MultiCloud Conference, Escape, because we need to talk about these things. I don't want to talk about them in the context of AWS and Google and like a single cloud provider. We need to talk about these things as a group because 4 years from now, 5 years, we will be living in that future and we will go through those problems. For instance, the Cockroach Labs team has some really interesting software engineers. Like, we're fixing things in our implementation of Raft. And if you don't know what Raft is, go check it out because it's awesome, right? Like, if you're new to this whole world and you want to understand distributed systems, go read about Raft. there's an implementation of Raft that's done in etcd. Etcd going to be in a key piece of Kubernetes. Our implementation of Raft actually gets into federated and multi-region Raft. What are the problems we're going to see when latencies come into mind? Because ultimately, y'all, we're dealing with a battle with the speed of light. That's our ultimate enemy when we start to deal with these multi-cloud and federated items. And so like, we're solving problems there because we don't know what the problems are going to be though. And so for me, will we live in a multi-cloud world? Absolutely. It's not like the doubters, I kind of laugh. I'm like, yeah, the future is, this world where, Josh, I believe that hybrid is just a multi-cloud problem. It's two places, man. That's multi to me. And so I feel pretty strongly about it. I love this concept though. And I love this part of the conversation. So if you can't tell, I am a little emotional, but hey,
No, that's good. And it's funny. We often get wrapped into the kind of like the dogmatic views of what it needs to be. But in practice, we know we have to have a very open, I love your description. We are all living in the future right now, and we're writing it as we go.
We are.
And so it's kind of neat. Jochen, I'd love to get your thoughts on, what does the multi-cloud world look like to you and your team and your customers?
Well, I fear I have to go a little into opposition to some opinions on the multi-cloud version. We're running an infrastructure in multi-cloud, and one of the things we do is we run our own data stores for the super cost. For us, it's more cost friendly. With the amount of data we're pushing around when doing all the tracing that we do for the customers, the costs don't add up. And for us, the flexibility that we get for clouds is great. And it's something that we use right now. But going back to my consulting perspective, I would actively discourage customers from going multi-cloud for the simple reason that for most companies, it doesn't make sense. It makes sense to go full in on a cloud in most scenarios because you have to train your developers. And seeing actually the payoff from going multi-cloud is maybe way ahead in the future, but most companies don't earn money by being multi-cloud. They earn money by solving specific problems for the customers and the scenarios they're trying to solve. So if I see a customer who actually gets benefit from going multi-cloud, I would actually recommend them to do that. But most customers, smaller companies, I don't see them. The effort to actually do multi-cloud don't offset what you have to put in place to actually be able to do multi-cloud. I have to add additional infrastructure. I have to do a lot of things to actually be capable of doing multi-cloud. And the other part is, even if my application could be run in multiple clouds, the question is, am I really open to restrict the amount of services I want to use from a specific cloud? There's this old thing where we say really going true hybrid, and true hybrid cloud was when we go 2 or 3 years ago back, was I can just dump my application, whatever cloud provider I want to use. That's not the case. And I also agree that I see a lot of companies using different clouds. For example, I see I don't want to mention the big ones, but there's we have one cloud that is pretty good with data crunching. We have another cloud which is pretty good with running applications. Now the problem is if you I want to do the data crunching and I want to present it in my applications, how are you going to do the data transfer? How are you going to pay for the data that you're transferring between those clouds? Because that's always the outgoing traffic, which you're going to pay extra. So there's a lot of stuff still to solve. And with cloud providers wanting to iron out their walled gardens, I don't see that coming together. Maybe for big companies, but with medium-sized and smaller ones, I see a big border to actually get there.
Yeah, it's a good point, Jochen, and it becomes this challenge of I love how you highlighted that. It's that you've got the data strength, ML strength. We've got, other services strength. You've got all these sort of positives and negatives. It's very interesting. And Endre, if you don't mind, before I jump in and I get to you, because I'd love to get your thoughts on this one. I also want to welcome, we've got 2 new panelists that just jumped on. We had some challenges at the start. So a big warm welcome to Shrey and Jeff, who are coming to us from AppDynamics. Shrey and Jeff, if you want to introduce yourselves to the team here, and we are live streaming as we go, so welcome aboard.
Great, thank you so much, Eric, and apologies for joining a little bit late due to technical issues, but my name is Shrey Parekh. I come to you as a product and solutions marketing manager at AppDynamics, which is of course part of Cisco. And my focus areas are on multi-cloud, Kubernetes, serverless, and a lot of our next generation solutions that we're working on in alongside our Cisco business unit partners.
Excellent.
Jeff?
And Jeff? Oh, we've got Jeff muted, I think. One moment.
Yeah.
Sorry about that. Jeff Holmes here. I am a field architect in our pre-sales organization focusing on cloud and containerized environments, and very nice to be here. Sorry.
Excellent. Thank you very much both for coming. So Endre, just to sort of carry on what we were talking about, the cloud made of multi-cloud challenge, what has multi-cloud in practice looked like in your experience in these environments you've talked to?
Yeah, so I really liked another point that Jim made about we are in the future. What I think is interesting is how far are we in the future? Is it like part 1 of Back to the Future or part 2 or part 3? Because multi-cloud has different meanings, and I think it's worth qualifying exactly what we mean in different contexts, and all of them are valid. So one of the terms that I think Josh used is portability. Is, do I have the ability to deploy and redeploy my application someplace else? I think that's a fair definition of a multi-cloud. I think Jochen made a very good point that it doesn't mean that you always have to do that. There are, I think, certain use cases and certain applications where that is beneficial. For example, I'm working with a customer who is in a B2B business. Some of their businesses that they sell to have to be regulated, they have to be on certain premises. Some of their businesses that they sell to have to be in one region, they have to be in a particular cloud, but they do want to offer the same application to all of these B2B businesses with the same orchestration. And obviously Kubernetes is a huge advantage for them, but their business requires them to be able to deploy this in multi-cloud and even possibly across multiple clouds. So I think that when your business needs it, it's probably worth the investment. I think that as geek as I am, just for fun, it probably doesn't make financial sense. The other point is beyond the portability of the application. Maybe Back to the Future number 3 is when you actually can connect applications between multiple clouds, deploy different components of the application across multiple clouds. One example would be that if I want to run some of my applications in my own data center, but under certain loads. I worked with a medical healthcare company that wanted to be able to serve certain campaigns, and they needed to be able to scale from 1,000 users to 50,000 users, and for them to be able to run part of the application, scale part of the application seamlessly into a public cloud is critical to their business. They cannot possibly buy all the hardware on premises, and some of these campaigns would just simply fail and they would never go anywhere. So if they did that, they would be wasting money anyway. But again, it's a specific business problem that they need to solve. And in that context, I think it makes sense. Or I could maybe mention our own software where we find that there are certain components of our software that are better ran on one particular public cloud, and there are certain components for various security reasons that has to be hosted on another cloud. And we have been able to connect these things together through a single control plane, multi-cluster Istio service mesh, which is super cool. But I'm not doing it because it's cool. I'm doing it because I had to. And so I'm definitely living in the future, but I think with Jochen's point, it is for the right reasons, for the right business reason. And I think that, for example, the references that were made on how to actually leverage these multiple services across multiple clouds by Bassam and team is really important to show people that it is possible, so that you don't stop yourself from solving a business problem because it's not possible. You choose the right technology when you have a business problem to solve. And I think that there are business problems that will require us to actually develop and deploy and operate applications across multiple clouds.
Yeah, it's a great point, Endre. And if I think of way back, we P2V was the original sort of like, hey, we've got a new architecture. We can take something that worked and let's move it over, which was in hindsight, a profoundly poor idea. Like most of we did a lot of things badly in order to adopt the new architecture. But then, as you say, now that we know we can do it, we will architect towards it rather than just, just drop into it and hope that it works. And something we're lucky more than we're right for when in those early days. So it's good. Shrey and Jeff, you obviously have an incredible insight into the user experience in that side of the world. So as we're seeing companies take on cloud native, what does that complexity and connectivity play out like, in your customer environments? Obviously, we could talk about AppD, but I'd just love more to get to, like, how did the customers adapt to using cloud native and understanding how it operates?
So I can get started first, Jeff. So just to provide some context, when we're looking at cloud native within AppDynamics and Cisco, it's really around taking the lens of, now that we're in the era of observability and extensibility, we want to be able to make our platform as extensible as possible for our practitioners who are using the product day in and day out. And so when we're looking at cloud native, we're looking at ways in which we're building our solutions. And the perfect example of this is our cluster agent, which we see many customers utilizing for their Kubernetes environments when they're looking at ways to fully monitor and optimize their container environments and container orchestration vehicle using Kubernetes or other solutions. And especially with the time that we're in right now, we see greater adoption of both multi-cloud as well as hybrid cloud approaches, with customers looking to ways to more optimally migrate to the cloud. But then even once they're in the cloud, how do they ensure that they're fully monitoring and optimizing their solutions? And then, of course, the cloud native approach, which is all looking at our customer base and prospects that are looking at ways to continue to adopt cloud native services and serverless. So that's really top of mind for our product management team within AppDynamics and Cisco.
Yeah, and I would add that definitely a big pain point for the customers we're dealing with is initially it was the movement to hybrid cloud deployments and now multi-cloud, but being able to kind of maintain visibility as they're moving workloads and services and being able to track where there are performance issues. That's obviously a huge kind of monitoring problem when it comes to these kinds of deployments, and that's really where we're focused is being able to see beyond what the cloud tools provide, and in terms of in a lot of cases just visibility within the cloud, and using our tool set to expand that and be able to see, for example, interactions across services running in various clouds or in hybrid scenarios, being able to troubleshoot that and being able to not only resolve issues very quickly, but also provide visibility into provisioning, are you over or underutilized, and business performance, as we say, what kind of KPIs are you tracking across these deployments.
Yeah, and if I think of a shout out to our friend Randy Schaup, who says that microservices is SOA done right. Like, we've been talking about service-oriented architecture and resource-oriented architecture for as long as I've been in the industry, and we're seeing that really come to fruition. But with it becomes a change in the way that we adopt and do things. And I think the most important thing that's come up throughout all of our discussions here is the word automation is a profound part of success in doing what we do. And maybe with that, I'll kind of work backwards through the folks we just talked with. Jeff, I'd love to hear your thoughts on how important, it sounds like a very Larry King, how important is the automation? So how important is automation in successful cloud native architectures and adoption?
Well, I think the first thing I'm thinking about is our as an example of automating validation of your deployments as you're moving into the cloud. Our integration with Harness is a great example where we're working with with Harness as a partner, providing the insight that we can collect through our APM tool set, so that as you deploy your microservices and migrate them, you can validate automatically that your deployment is working, and remove some of the manual intervention required to say, here's a new version of my service deployed to the cloud. Is it working as expected? So I think that's one example where we're kind of focusing on the automation perspective and being able to support quicker continuous delivery kinds of practices in a cloud native.
Well, it's really great because I remember the early surge in test-driven developments, which I moved into my own implementations of test-driven infrastructure, and making sure that as we deploy and operate new things, that we should be treating it all as continuous testing. So I should know it should fail, and then I should know when to find that activity as occurring.
Yeah, I think that's for us, that's in our customers, like being able to integrate that into your build pipelines and deployment pipelines, and being able to leverage AppD in those kinds of pipelines to help make those kind of automated decisions is pretty huge.
And Shrey, what's your experience in moving towards that, and what are the kind of where are customers doing it well, and how do people get towards that? Because I think that automation is great, but sometimes I find we can be speaking to a captive audience, or we're the preaching to the choir sometimes. How are the early or the late adopters of that automation coming to learn how to do it well?
So with late adopters of automation, what we're seeing is that generally it is there are systemic reasons why they tend to be late adopters of automation in general. It could be industry factors that they're in, more highly regulated industries in which they're moving at slower paces due to regulation. It could be the larger sort of corporate roadblocks that they're running into in terms of how fast they can actually deploy and how agile their software development teams can be, or more macroeconomic trends like the ones that we're seeing now. So what we do is we look at our customers on an account by account basis and by industry vertical, as well as just getting to know some of these more systemic issues that are arising. And the way that we encourage more later adopters to be able to take advantage of the automation software, as well as the partnerships, as Jeff mentioned. Harness is a perfect example of one of our partnerships. Another one that we have right now is with Rookout, and that enables sort of real-time debugging in code without sort of any sort of major delineation of breakpoints needing to happen within your live code environment. And so, in showing real life customer use cases, fast time to deployment, faster sort of mean time to resolution being experienced across our customer base with our early adopters of automation, we hopefully are then changing the mindsets of our key stakeholders and our champions within the organizations that are adopting automation later in the process, or in their sort of pipeline. And so we're seeing really good use cases and customer examples coming up, especially as we continue to evolve the partnerships that we have in what's known as the Integration Partner Program, or IPP for short, that we have at AppDynamics and Cisco.
Nice. And I think a good question that actually, beyond just automation, and we'll touch on it real quick, but as we head into coming out of this automation discussion, great question that I love is, what do we think computing is going to look like in 18 months while we're living in the future now? It's a neat thing. So Jochen, maybe if you want to split the line on that one, let's talk about the importance of automation, because you really nailed it in your first segment there. How fundamental is automation, and then what does 18 months from now look like in your world?
In my world, it's like the automation is the core. Like everything we do at Instana is fully automated for the simple reason that it's simple. Like keeping information in the heads of people is a very dangerous thing for any operation to do. So what I see is just that we are right now at the very beginning of actual automation. I mean, when we talk right now about automation, I think like the most thing that people think about is continuous deployment, continuous integration, combined with some terraforming of our application infrastructure and maybe some auto scaling. But I see a lot more potential. I mean, like with Instana, I mean, like we know AppDynamics, and like it's pretty similar to what we do. We have the profiling aspects and everything. So like the amount of information that we get for the future for actual automation, like going into the direction to see like how a rollout affects everything, even like going towards like architecture verification automatically, where you see like you define like a certain layout of your application, and you see like new connections spring up that you don't want or can be costly. Going to a point where you, like if we really talk about shifting loads between environments, where like you're now able like to like monitor like the costs of certain resources in another cloud vendor and being able to automatically shift things over because you know that you can run these workloads over there. These are things that are immense, I would say they're not to be handled by humans. Like they need to be automated. It has to be a reaction by the system. So what we have right now is we still have a rather static view of automation. Like we define a system, we expect a certain layout to come up, we have a certain set of reactions that we know of the system can take. But with the amount of insights we now get out of system, like additional profiling, metrics, deeper like in tracing and everything, we suddenly get informations about the system that can go into a feedback loop with our automation. And that's the future I'm hoping for, because that's like the actual automation. Like automation right now is just like avoid repetitive tasks and avoid knowledge being stuck in people. Like that's like, I mean, like we were pretty good with that right now. And I hope like that we get forward where we have this full feedback loop, where we get like the whole insight on our cloud infrastructure back into our automation and have the system really start reacting automatically. And that's the automation that I'm hoping for when I see. I mean, like I'm a geek. Like I just hope that one day the system is just going to ask me for my credit card number. It's going to do everything on its own.
Well, and the autonomous future really is that's really kind of what we're aiming for. It's not just automated, but autonomous, and it is a fundamental shift. It's neat. Josh, I'm curious your thoughts on how has automation become both prevalent and fundamental in the shift to cloud native, and what does that world look like to you and your customers in 18 months?
Well, I think I really have to second what Jochen just had to say, and in the book we wrote with O'Reilly about operators, which is just sort of an implementation of these ideas. Like it's just one manifestation. It's where we at Red Hat and at CoreOS have decided to put some of this thinking. But there's kind of a platonic idea of automation. And if you think about, I think a lot about autopilot systems, and I don't know a lot about airplane autopilot systems, but like if you look at autopilots on boats, especially fishing boats, this kind of early stage autopilot where it's like, I can set a bearing from a compass and it'll try to hold that bearing and drive it in a straight line. It doesn't know much about the state of the throttles, whether both engines are running properly. So we start adding things to it, like a rudder position sensor, which tells me if I'm having to steer at yaw to a group of incoming waves. And so these things are going to apply to an airplane autopilot system too. As we increase the complexity of that feedback loop and feed more and more information into systems that can make decisions with that information, automation starts to be something that is as meaningful at the infrastructure provision layer as it's become in some of the most advanced user level applications, like airplane autopilots that we've already, like that the industry has already shipped over time. So the real lesson here is, we build user applications to apply computing power to problems. A lot of this is about turning that computing power in on itself and using it to regulate, monitor, and make decisions about the behavior of the systems we're actually running. And I think as we are more and more capable of knowing what metrics make sense, more and more capable of programming systems that respond intelligently to them, we move kind of in a progression from today's automation is about for me and customers I talk to, like there's 150 or 200 operators in the operator hub and in kind of Red Hat's lists of which partners and community members are building these things. A lot of them are all about how do I install the app on Kubernetes, keep it running there, and maybe do a little bit of failure recovery when the app has really complex internal state, like more than K8s itself can manage to deal with. But there's a whole other world beyond that of responding to performance metrics to make auto scaling decisions, especially those decisions that might scale something down for cost saving efficiencies at low load times. That I think will be more and more what we see kind of programmed into this space, and is why the future of it is actually exciting, because I think this principle underlies a lot of what Google originally had to say about site reliability engineering, which is if you free human engineers and teams from toil, from repetitive stuff, they actually have time to invent cool new things. And so we can start to see applications that, instead of being Unix applications that go in a container and get orchestrated, are actually cloud native at the app layer, like start leveraging the nature of the platforms we're building with distributed thinking built in, with automation built in. And I think over time, we'll see people build really cool applications because that application's green field began in a world where automated distributed concepts were table stakes.
It's and beautifully put, Josh. I like this idea that it's, yeah, I just be happy if I can get YAML files to write themselves. That's right now. That's kind of where all this amazing automation and then YAML stuck between it. But we'll get there. We'll get there. And Jim, I saw you were with me. You were excited and on what Josh and what Jochen and everybody was bringing up. I'd love to get your thoughts on this piece.
You know, Josh and I come from a very similar place in that if we can instill the cloud native primitives and principles of development and systems into every layer of that stack, we will become autonomous. We will basically, you know, self-driving infrastructure, Josh, right? That was like our, you know, when CoreOS came out with something called Tectonic, it was, you know, their version of Kubernetes. I mean, it was basically pulling together, look at container Linux. Oh, can we automate like the updates and the security of that layer, right? Within a container, right? The OS. You know, Kubernetes was self-healing and basically, you know, you can't kill it, right? Like that was great. And then with the introduction of operators, it was really that moment in time. I remember at CoreOS where, I mean, we actually called them controller operators first. And we were like, well, actually they aren't controlling. They are operators, right? And so like bringing that through those layers of the stack, but being fully automated and being kind of like API based and letting each layer deal with this automation, it was really critical and a really important moment, because we ended up calling Tectonic, it was like, yeah, self-driving Kubernetes. I mean, wouldn't that be great? But you know, yeah, we're living in the future. But I think the core principles of systems and doing this in the stack, and one of the reasons I ended up at where I'm at today is because we need to think distributed. We need to think the smallest atomic unit, the self-contained unit of code. We need to think about shared nothing. We need to think about resilience, and we need to think about scale. And if we think about those things in our applications, you don't need you need operators to do like automated scaling and that sort of things. Like, but that's different. It's like inside the application itself, it can automate these things. And there are systems and there are applications that are designed in this new world. It's, you know, I think, you know, Brandon Phillips was also one of these. I hate keep going back to CoreOS, but you know, he had this concept, you know, GIFY, Google infrastructure for everybody. And one of the things that those engineers, and they were living in the future that we're in today, by the way, y'all, like,
yeah, they got their minds were already leading towards
exactly.
We finally gotten here.
Like they're laughing at us, right? Like, but they design these things into the applications themselves, and that's how you get to this point. And I just wanted to double down on something that Josh had said. It's like it takes basically all the layers of that stack to get to this point where we're automating these things out, where we truly do get to a world where it's you know, yep, I no longer have to park my car. It basically, you know, parallel parks for me, right? Like we'll get there. It's just like legacy systems need to be redesigned and re-architected. Like for us, it's the database. Like the old world database doesn't work in this new world. So let's re-architect it. let's make it cloud native, and let's just start picking off the layers of the stack and do that across the board.
Amen to that. Indra, you're you know this story near and
Yes.
dear to your
So
day-to-day.
I think really good points were made. I want to maybe just introduce a term. I think that what helps me as I'm discussing this with customers is to differentiate between process automation and decision automation. Process automation, where you take a repeatable task and then you make it do it by software, which is great, and it's very important, and it requires the APIs, it requires the infrastructure to be elastic, otherwise you can't do that. It's a foundation, but on top of that, what we're really, I think, pointing to, and hopefully this helps to answer the question of where I think we're going to be. I don't know if it's exactly 18 months from now, but where we are going to is basically decision automation, where as Jochen pointed out, the software can take insights from the system itself, and it creates a feedback loop, makes decisions, and then leverages this automation that we have built before to actually execute those decisions. And I think that's really the point. And I think that the benefit of this is that we are somewhat obsessed with the infrastructure components. Which cloud I am running on? How do I install Kubernetes? How do I scale this application? What I think this decision automation allows us to do is to think about the intent. What is it that I want? As Jim said, I want to park my car. I don't care exactly what degree of the angle I need to turn the wheel in. I want my car to be parked. Make it happen. Read your insight, make decisions, park my car, right? So how do we enable our customers to try to focus on the intent, focus on what level of service they want to provide, and let the software make decisions and automate those decisions so that it continuously accomplishes that particular level of service?
And the intent is such an important piece, and luckily we're starting to see it come in small portions of, but again, to what a lot of folks have said, we've been hearing these phrases for a long time, but now they're a little bit more mainstreamed, luckily, as a result of innovation that's led to longevity in that innovation. And we've seen stuff go by the wayside. Kubernetes clearly has kind of landed. Question that came from the audience, and I wish we could go across the entire panel for this one, but as somebody who creates OpenShift and OpenStack infrastructure, Josh, I'm going to leave you to close us with, are we ready? You know, someone said if we were worried about Linux back in the day, no one questions it now, right? But Kubernetes is, I think, at the we've landed. We figured that this is going to stick, but where do you think we are in the evolution of the readiness of us and as Kubernetes as a platform?
Yeah, I don't know if I'd venture to say that human beings in general are ever ready for anything, right? I think we all make it up as we go along to a certain extent. And I think there's power and emotional fulfillment in admitting that. But here's what I think. I think the best way I can address that is say that it's a really enjoyable conversation when we get to talk about the future. It's always also good to circle that back and think about the present for a lot of developers. And in the name of trying to build architectures on top of which we can build all these kind of ideas of automation, from process to decision automation, we are changing how developers approach their daily work, what their build pipeline to deployment looks like. Sometimes, and I'm certainly guilty of this, even in kind of envisioning the future, I am envisioning a more complex programming environment where developers have to think about distributed systems concerns and automation concerns of designing for failure. So the trick is, I think, like what we're trying to do with OpenShift and a lot of the stuff we work on across the board at Red Hat is, if there's a penalty imposed for moving to this kind of beautiful new vision of the future, can we also leverage that same automation to ameliorate that penalty? So the more that operators are brilliant and we could maybe program decision automation in them, are we doing enough today to program process automation that just makes it really easy for a day-to-day developer to grab a database and run it reliably and to move it from his dev environment, his or her dev environment, right into production, so that those are kind of reproducible. This same automation that is fun to be Jules Verne about and is happening at the leading edge of the market can also help developers play and get in the game, instead of the proliferation of services and the complexity of design just going up and up, and my build pipeline just getting longer and longer, and I feel like I understand less and less about what's happening to actually deploy my application and make it run in the real world. So again, I think our theme's been automation. And so from the top layer and the most fanciful visions of the future to the how do I do my work today, I think automating on top of this really popular platform, Kubernetes, can give help to both sides of that question.
We're heading in the right direction. With that, I wish we had another hour. It's been an absolute pleasure. Big thanks to all of the teams at AppDynamics, Cockroach Labs, Instana, Red Hat, and of course, Turbonomic. Thank you to all of our panelists for this great discussion. And it's been a pleasure. Make sure, folks, stay on the stream. We've got another day and a half of great content ahead. So with that, this is Push to Prod. This was our panel for today. And my name is Eric Wright. Thank you very much and have a great day.